Hello, my name is Ismat Agayb and my classmate Rustam Asunov and we are going to present a topic named Echo Cruise Control today. So what's Echo Cruise Control? It's basically the system that gives the information, topological information to the vehicles in order to minimize their vehicle fuel consumption. It has several sub areas. We will use Echo Cruise Control for traffic light systems. It's basically giving a prior information to the vehicles so that they can achieve their desired speed, so that they will not stop at the red light. In the steps of our program project is to create a road network using SUMO-Net edit, then create a vehicle routes in the route XML file, and we will use Traci library to have integration between Python and Sumo. We will write the algorithm in Python, and we will run the program Python and the Sumo file simultaneously, and at the end we will have a comparison between the fuel consumption of the normal car and the Echo Cruise Control car. So let me explain the algorithm from the Python file itself. We have two states of for simplicity. We just have two states of the traffic light, only green and red. We don't put the yellow light for the yellow phase for the traffic light. So we have 10 seconds for the green light and 40 seconds for the red lights, which makes total 50. So when we know the timer of the program, it's like iteration timer counter of the program. So from 0 to 10 it is 0 to 10 it is green, and from 10 to 50 it is red, and it continues periodically, so its cycle time is 50 seconds. So we also have the main algorithm here written here. So if we have a distance which is at least later less than or equal to threshold distance, this period distance, which is calculated to be 50 cycle time multiplied by the optimal speed, which is 500 meters in our case. So if we are more than 500 meters away from the traffic light, we don't need to activate the algorithm because in real case it is not it's not effective. So we just calculate the distance. If it is less than this threshold distance, we will check if we continue with this speed, and if we are going to cross in the green light, we don't need to do anything. If it will be a red light, we need to decrease our speed by this amount. This is just normal mathematical formula, and after knowing time and we also know the distance using the built-in functions from the Traci library, we just calculate the speed using the normal speed, time and velocity formula. So we set the speed for the vehicle ID. So when it comes to the network, we have let me switch to the inspect mode. We have network with 10 junctions. As you see, the red ones indicate junctions, and we have 11 edges. So we only put the traffic light to this junction name 2. So as I said earlier, we have two phases, only green for 10 seconds and red phase for 40 seconds, which makes total cycle time of 50 seconds. So we have 2 lanes here, 4 lanes here, 4 lanes here. Some of the lanes are 4, edges have 4 lanes, and some of them has 2 lanes. We can see from number of lanes 4, and this is, for example, distance of that edge, its names from which junction to which junction. So we can all change and create everything using net edit. So let me run the program. So we just press Ctrl B. So let's switch to the 100-second and put this type to the real world in order to be able to visualize everything more in a good way. So we have you see it's already in the red state because we are in the 17 seconds. From 10 to 50 it should be red, and it's also red. So our yellow car is the one with eco cruise control system activated, and this red car is normal car, the second vehicle with the ID2. So as you see, yellow car and red car start from same time from this position, but this car knows that if it continue with the optimal speed, it will eventually need to stop at this junction, but it decreases its speed to the desired speed so that it will not stop here and come and pass with normal speed. So if it passes from this junction, it will again have a desired optimal speed, which is 10 for, which is allowed, maximum allowed speed in these lanes. So we set them to be 10 in the code. That's why both of them continue with the speed of 10 after passing this junction. So let's continue to see the system, how it works. You see they eventually cross at, so this is our pass, total pass. They come again here. You see again, they will now continue with this pass, not this one. So program continues in this way. We can decrease the milliseconds to see the end of the program because we have two graphs, and I will explain both of them in the presentation file. So so as I said earlier, they both start in the same position, but the reason this vehicle, yellow vehicle, which is the eco cruise control system activated, is behind the red car because it knows that it will stop anyway here. So that's why it reduces its speed beforehand, because it has the information of this traffic light states. So we have two curves. We made a fuel consumption curve and the speed curve. About the fuel consumption, this yellow line represents the car with eco cruise control system available. The other one is normal traditional simple car. So we just get the fuel consumption using the built-in function of the Traci library. We just get this fuel consumption values in every iteration, and we made an average function for both of them. This is the final output of the code, which is this unit, and it's of course less than the normal simple car. So we have in total around 15% gain in the fuel consumption. So when it comes to speed comparison, as we see, our yellow car, which is the ECC car, it don't have any speed value which is equal to 0 because it don't stop anywhere in the road. But however, red car have a curve which have high values and low values even with a 0 value, because it reaches the junction at a 20 seconds and it waits for 30 seconds. This is 50. So you can see it's 50. It waits for 50 seconds for green light. However, this yellow car knows it beforehand. That's why it decreases its speed to somewhere like 3.5, not 10 maximum speed, so that it don't stop at the junction. And after junction, they both accelerate to their higher value. So this decrease in other parts of the road is due to because we have a very high turning radius, low turning radius in the junctions in the network. That's why it's like a built-in function of the SUMO, which needs brakes in that kind of tough ends of the network. So thank you for your attention. This was the whole thing we are going to say.